Hello everyone. I hope all of you are doing well in your studies and doing excellent in your studies. I'm Rahila Ehsan and I'm your physics teacher. Today we are going to start our new lesson, physical properties of matter. So physical properties of matter is very simple topic and very important topic from physics point of view. So these are the topics, titles that we are going to study or discuss in this chapter. So we'll start from the microscopic understanding of various states of matter: elasticity, plasticity, density, stress and strain, elastic moduli, Young's moduli, shear modulus, bulk modulus, application of elastic behavior of materials. So starting from the very basic, the phenomenon that we know that all materials exist in three states, in three phases. The first is solid, in which all the particles they are organized, or they are held in their fixed mean position. When we give heat to that, the particles gain potential. The particles gain kinetic energy so much that the phase is converted into mobile state, and on further giving the energy. On further giving the heat, the particles further gain kinetic energy, and so the particles move in a zigzag manner, and we call this state as a gaseous state. What is elasticity? Elasticity is basically relates to the property of matter by which of it tends to regain its original size and shape when the applied force is removed, is known as elasticity, and the deformation caused is known as elastic deformation. In contrast, the materials which lacks the tendency to regain its original shape are plastic materials, and the property is called plasticity. For example, mud and putty, or a greyish paste that hardens after a few hours, used in the window frames. Okay, so basically elasticity is the property of matter on which when you apply any force, any deforming force, the body quickly regain its original size and shape. Okay, so in this case we can say that steel is more elastic than rubber. Why? Because when you apply force on the steel quickly regain its original shape so much quickly that you cannot physically observe it, while plastic gains time. Why we study these physical properties of matter? Because it is very important in engineering designs. Like knowledge of elastic behaviors of materials like steel and concrete is essential in building mega structures, in building bridges, in building railway tracks. So designing of aircraft, designing of glass structures, these are very important. If we do not understand the basic physical properties of materials, we will not be able to build or to construct such mega structures. So in overall, the idea is that the growth of human civilization is due to the understanding of the various forms of matter, that is solid, liquid and gas. So you can see whether it is biologically, biomedical science, whether it is physical science, in all aspect, understanding the physical nature of the material is very important, and this lead to the advancement of human civilization. Now, what is density? Density is very important. You have studied this from the very beginning, from the very first classes, that density is the property of matter. What does it mean? That it tells us how concentrated the matter is in a particular material. Density is a constant for given material under specific condition. Density is defined as the mass per unit volume of a substance, and it is the formalized mass per unit volume. Its unit is kilogram per meter cube, and we can also write as gram per centimeter cube. So keep in mind that 1000 kilogram per meter cube is always equal to 1 gram per centimeter cube. Mean to say that when you convert 1000 kilogram per meter cube into gram per centimeter cube, it will always equal to 1 gram per centimeter cube. And density of water is always equal to 1000 kilogram per meter cube. Keep in mind that most of the time we take density of water as a reference material, is a standard value for measuring the densities of other materials. And when we do so, we call this type of term relative density or specific density. Here you can see the densities of various materials like gold, mercury, and up to the hydrogen gas, which has very least amount of least amount of density. So we will come towards the relative density or specific density. This shows the this is basically a relation. It is basically a ratio telling us the relationship between the density of water with that of the required material. So the ratio of the density of the substance to the density of water is called relative density or specific gravity. And so this is a ratio. It does not have unit. Okay. And how can we measure? We can measure it through this specific bottle, which is known as a gravity bottle. So from this equation, you can calculate the densities of the required material with that of the water. So you can see in this table that density of water is always 1. Relative density of water is 1. Okay. And when we compare the densities of other liquids or other material with that of water, it will have its different values. Now, elastic behavior of solids. What is elastic behavior of solids? You can understand through the spring ball system. Spring ball model for the illustration or for the representation of elastic behavior of solids. So this spring ball system, this model was given by a famous scientist named Robert Hooke, and he says that within any solid, the particles are closely held together, and we can term these particles as the ball. We consider them as ball held between the spring, and they consider the molecular or the atomic forces between these atoms as spring force. He considered it as spring force, and he says that whenever we apply force, what will happen? That the ball or the atoms or the molecules, they displace from the main position, and due to this, what happens? Due to this deforming force, an internal restoring force develops, and this restoring force quickly compels the ball to come into its original mean position. So this restoring force and this restoring force will be always equal to the applied deforming force. Okay. So the force between atoms or molecules can be represented through springs, and this restoring force will be responsible for the shape or the size of the solid. Now, what is stress? Stress is when a body is subjected to a deforming force, a restoring force is developed in the force. So the restoring force per unit area is equal to the stress, and its unit is Newton per meter square, and its dimensional formula is mLT. Now, types of stress, basically there are 3 types of stress: longitudinal stress, shearing stress, and volumetric stress. What are longitudinal stress? Longitudinal stress is the normal force applied on any object. The normal force when applied on the object is called longitudinal stress, and this normal force can be of 2 types. It can be either tensile stress, or it can be a compressive stress. When we applied such a deforming force on the object, in which the object elongates, in which the object size increases, we call this stress as the tensile stress. Okay. On the other hand, if we apply a deforming force such that the size of the object decreases, the object shrinks, we call this stress as the compressive stress. Shearing or tangential stress is developed when shearing stress or tangential stress is not a normal or perpendicular stress. Okay, like for example, if you apply perpendicular force on this object, we call this a longitudinal. But if you apply an oblique force, okay, not a straight force, oblique force, what will happen? The object the displacement will cover a displacement. Okay, I mean to say that the object the change in the size of the object will be different from that of the previous one. Okay, so this tangential stress is is not physically observable, but it happens in the materials. Okay, why? Because the theta is formed. So this theta is equal to tangential stress. Why tangential stress? Because displacement is formed here. You can see displacement. The object discovered a displacement over here. So tangential theta is equal to perpendicular over base. So delta x over the height of the object. Volumetric stress, whenever whenever a force is applied on the object, like for example, if we immersed any object in a liquid, what will happen on the object? At every point force is applied on it. So we can say that volumetric stress is applied on the object, and the formula is given force over area. And in simple words, we can call volumetric stress as the pressure of the liquid. Strain again, the change in the size of the object due to the stress is called strain, and its formula is given change in the size over original size. And it is of three types: longitudinal stress, strain, shearing strain, volumetric strain. Longitudinal strain is due to the longitudinal stress, or we can say that when a rod of length is pulled by equal and opposite forces, the longitudinal strain is defined as increase in length of the rod over original or natural length of the rod. It again can be classified into two types. If the length is increased from its natural length, then it is known as tensile strain, or in simple words, tensile strain is due to the tensile stress. Okay, and if the length is decreased from its original length, then it is known as the compressive strain, or in simple words, we can call that if tensile compressive stress causes compressive stress. Tangential or shearing strain is due to the tangential stress. Okay, and the strain produced due to the shearing stress is called shearing strain. It is the ratio of relative displacement to the length of the object. Relative displacement, you applied an oblique force on it, and as a result the shape of the object change by delta x. Okay, and making an angle theta, tangential tan theta. So this tan theta is equal to change in displacement over base over height of the object. You can see over here this object as well, tan theta is making angle, and this angle is equal to displacement of the object over its height, which is the base. Tan theta is equal to perpendicular over base. Volumetric strain, the strain caused due to the volumetric strain stress is called volumetric strain. And again we can say that volumetric stress, or simple words, pressure causes strain in the shape of the size of the in the shape or size of the object. So this was our overall topic. I hope that you have understood. So have a nice time. Goodbye.